All right, so we realize that this is not factorable, and so that means that we are going to have to complete the square. Sorry, so we can just cross this out. All right, so how would we complete the square on this? All right, so first of all, we need to divide 3 out. So we have x squared minus 15x plus blank, remember, and then minus blank, and then we've got the plus 125 on the outside. All right, so we would continue by filling in the blank. So remember, the blank is going to be half of 15 squared. So it would be 15 halves squared, right? And remember, 15 squared is going to be 225 divided by 2 squared, which is 4. So this is going to be plus 225 fourths. Minus, now remember, this is not 225 fourths because it is multiplied by 3. So that would actually be, 3 times 225 is 675 fourths. All right, so now I have 0 equals 3 times. This becomes x minus 15 halves squared, and then I have negative 675 fourths plus 125. So remember, 125, if you multiply by 4, would be 500 fourths. So that gives me negative 175 fourths. All right, so now in order to solve for x, I'm going to add 175 fourths and divide by 3. So I have x minus 15 halves squared equals, I added 175 fourths and I divided by 3, so that becomes 175 twelfths. Then I'm going to square root and add 15 halves. So x is equal to 15 halves plus or minus the square root of 175 twelfths. Now, we could simplify that ever so slightly, 15 halves. Now, you know that 175 is, 25 times 7. And so you could bring out a 5. So 5 root 7 divided by, and if you rewrite 12 as 4 times 3, that would be 2 root 3. So, you could rewrite it again and say 15 halves plus or minus. If you bring the root 3 over root 3, that could become 5 root 21 over 2 times 3 is 6. So this is what you could say. All right, so now what you want to do is you want to verify that V would actually have a maximum at one of those values. But we want to remember here that 15 halves plus this is one number, and 15 halves minus this is another number. All right, and so what we want to realize is 15 halves, well, that's like 7.5, right? Plus or minus 15 root 21 over 6. All right, so root 21, remember, that would be between 4 and 5. So 5 times between 4 and 5 would be a number between 20 and, a number between 20 and 25, right? And so a number between 20 and 25 divided by 6 is around 4, right? So let's say it's around 4. All right, so 7.5 plus or minus around 4, right? So are both of those reasonable? Well, think about it. If this is 20 wide and I cut 7.5 plus 4, that would be 7.5 plus 4, that's 11. So I can't take a square of 11 off of each side because this thing is only 20 wide. So actually the 7.5 plus 4 is outside of the domain. So 7.5 minus around 4, that would be around 3.5 or so. Okay, which, well, that is acceptable. All right, and so what we want to do is we want to verify that there is in fact a maximum at 15 halves minus root, 5 root 21 over 6. All right, and so our our factor of the derivative is, let's see if we write it like that, 3 times x minus 15 halves squared minus 175 fourths, right? That's the derivative. So if we pick a number to the left of that, around 3.5, all right, we should get a positive value. All right. And then if we pick a number to the right of that, we should get a negative value indicating that we would achieve a maximum at that location. All right. And so then how large should the squares be? Well, they would be approximately this value, right? So x is approximately, x would equal that, and then you can get a decimal approximation. All right, and then what is the resulting value? So how do you do that? Well, you take that and you plug it into the original volume function. All right. So that's example number 2. All right, and then example number 3. All right, a rectangle has its base on the x-axis and its upper 2 vertices on the parabola y equals 20 minus x squared. What is the largest area the rectangle can have? And what are its dimensions? All right, so you're given a picture here, but maybe you wouldn't be given a picture and you might have to draw it. But anyway, this is the rectangle here. You can see that. So how do we find the area of a rectangle? Well, we basically take the width, right, by the height or the length, whatever you want to call it. All right, so what is the width? Well, the width would actually be 2x multiplied by the height. What's the height? Well, it's actually just the y value. So the y value is 20 minus x squared. So what do we want to do? We want to find the largest area, so we want to maximize a. So how are we going to maximize a? We're going to find its derivative, set it equal to 0, and figure out where it goes from positive to negative. All right, so first of all, I'm going to multiply this through. I'm going to rewrite it as 40x minus 2x cubed. All right, so now I'm going to take the derivative. So that's 40 minus, not 3, sorry, 6x squared, right? So now I set this equal to 0 and solve. So 40 minus 6x squared. So I'm going to add 6x squared and divide by 6. So x squared is equal to 40 over 6. Right, which is 20/3. And so x is equal to plus or minus the square root of 20/3. All right, and so now you want to think about, well, could x be positive or negative? Well, if x is positive, right, that would mean that the area is 2 times root 20/3 times 20 minus, right? But if x is negative, then that would be 2 times negative 20/3. Right? Which, well, that doesn't really make sense. So the positive root 20/3 is the value that we want to check. So now we're going to think about our sign analysis. So the square root of 20/3, all right? And so that is 0. So now what are we expecting to get? If we pick a number to the left of this, well, how about like 0? Well, what is the square root of 20/3? Remember, 20/3 is a little over 6, right? So that would be like 6 2/3. So if I take the square root of that number, right, we think about, well, square root of 4 is 2, square root of 9 is 3, so it's a number between 2 and 3, right? So if we pick a number to the left, we're expecting to get a positive value. So let's pick a number to the left, and we're going to plug it into that 40 minus 6x squared. Now, we don't always want to choose 0, right, because sometimes 0 doesn't make sense, right? So better to choose like 1 or something. So how about 40 minus 6 times 1 squared? Of course, 40 minus 6 is positive. All right, then pick a number to the right. We said that square root of 20/3 was a number between 2 and 3, so how about 3? 40 minus 6 times 3 squared. 3 squared is 9. 6 times 9 is 54, so 40 minus 54 is, of course, negative. So we get changing from a positive to negative. So the question, though, said, what is the largest area the rectangle can have and what are its dimensions? Well, the dimensions would be what? Well, the width isn't the square root of 20/3. It's actually 2 root 20/3 times, right? Or you would say by the height, which is 20 minus the square root of 20/3 squared, right? So what is 20 minus square root of 20? Well, square root of 20/3 squared is just 20/3, right? And so 20 minus 20/3, so 60/3 minus 20/3 is 40/3, right? So those are the dimensions. And then what is the area? Well, you would just multiply these, right? You would find the area by taking 2 times the square root of 20/3 times, well, remember the area function is, well, that's what we just used, 20 minus square root of 20/3 squared, right? And so you end up with 20 times the square root of 20/3 times 40/3, right? So obviously you could, play around with this a little bit, but basically that would be your area.